Alrighty. A particle is projected with velocity v, with velocity 15 meters per second at an angle theta to the horizontal. If I is along the horizontal and j is vertical upwards, and if cos theta equals 3/5, express the position vector r of the particle after t section in terms of I and j. That's fair enough. None of us have done one like this before, so alright, we can do that. For argument's sake, imagine that you throw it here, and at one point on your journey, I'm just going to make up a number randomly. Let's say, for argument's sake, it's 30 and 50. What does that mean? 30 meters across and 50 meters up. Your position vector would be 30i plus 50j. That's what that essentially means. So, to get the position vector, it's basically sx times I plus sy times j. You just insert the sx and sy equation into R and just put an I and a j beside it, and that's your position vector sorted, okay? We'll do that in a second. Now, next thing after that is we gotta break up that angle. So you throw it up at 50, and it's an angle of theta, okay? So we got 50 here, and there's theta here. Now we know the values of theta though. That's the only thing. We know that it's a 3, 4, 5 triangle. Adjacent is 3, hypotenuse is 5. If you use Pythagoras' theorem, you'll find out the other side is 4. This means cos theta is 3/5, which you already knew. Sine theta is 4/5. Okay. Next piece of business you're going to do is, if it's the adjacent side, it's 50 cos theta. If it's the opposite side, it's 50 sine theta. Everybody remember we did that the long way the other day? Okay. Now, what is 50 cos theta? Well, it's just 30 and 40, isn't it? Because 50 times 3/5 is 30, and up here would be 40. Okay, happy days. Next thing you're going to do is you're going to do your formula, your formulas of doom, so to speak. So you're going to go for Vx first. What's Vx, lads? The speed along the x direction? 30, and it ain't changing anytime soon. Okay, Vy? Yeah, does it want me to do that? Yeah, it's not yet, no big deal to do with that. 40 minus 9.8t. Sx then? 30t, and then finally sy. 40t, half the second one then. 4.9 squared. Right. And you have your 4 equations good to go. Alright, next thing we're going to do is just get the answer to part 1. So what's your position vector in terms of t? It's 30t times I, it's your sx, then your sy, which you'll just put in brackets. So anytime you put in a value of t, it will give you your position vector. So for example is, if I threw in t equals 1, the answer would be 30i, then 40 take away 4.9, which would be 35.1. So after 1 second, you'd be 30 meters across and 35.1 meters in the air. That's all that formula does. Just tells you where you are at any given point. Okay? Now, yeah, done. That's the first part done. Find the magnitude to the nearest meter per second and the direction to the nearest degree of the velocity of the particle when t equals 1. T equals 1, I reckon we're still on our way up or your way down? Probably still on our way up. Okay? So, that's the answer to the first part there. Okay? Sorry, should probably use a different letter for that, because the same letter as range, isn't it? So, say P is your position vector, and that's your position vector, okay? Now, that's that question done. Next thing we're going to do is get Vx and Vy. So Vx always stays at 30. Vy is different because it's 1 second in. So Vy is 40 take away 9.8 times 1, which makes that 30.2. Now, I'm just going to steal this right angle triangle up here. And you're going 30 across, you're going 30.2 up. Roughly what angle are you expecting? Very close to what? Very close to 45. Because the adjacent and the opposite are nearly equal, okay? Let's call it a letter I haven't used yet, A. So how do I find the angle? Tan A equals opposite over adjacent. And then tan inverse that. Shift tan inverse 30.2 divided by 30. And big one, make sure your calculator says D, not R or G. Always has to say D. And you should get 45.19 degrees. Once it's the nearest degree, so 45 degrees, okay? How do you find the speed of it? Anyway, how do you find the speed? Pythagoras' theorem. So it's going to be 30 squared plus 30.2 squared. And then square root your answer. 42.57 to the nearest meter per second though. So 43 meters per second. 43 meters per second going at an angle of 45 degrees upwards. Everybody cool with that? Get the range. Alright. How'd you get the range? Yourself, sir. You, yeah. Yes. Your Sx, yeah? Yeah, which is Vx times t. How do I find the time though? Yeah, exactly. Your Sy equals 0. Your Sy is at the bottom, which means you have no displacement above ground. No displacement above ground means you're either at the beginning or the end of your throw. So let's do Sy equals 0 first. Get rid of this now. Put equal to 0. Take out t. And you get 40 minus 4.9 t. This implies 4.9 t. 4.9 t must equal 40. And t is, what's 40 divided by 4.9? 400 over 49 or 8.16. Where possible, keep it as a fraction. Fractions are better. Alright. Into the range now, yeah? So this is quite an easy question to start off the day. So 30 multiplied by the time you're traveling across. So multiply the answer that's saved in my calculator by 30. And we get, yeah, I think we'll use 244.9. Do I have to round it off or anything like that? The nearest meter? So 245. Alright. Alright guys, let's try a few more of this. Question 10 is ordinary level. You could ask that an ordinary level test, okay? So we're going to go for something a bit more fitting to us. Alright, you guys try question 14, so is that for homework? Alright, I'll just correct it, so if that's the case. I'll give you another one after that then. Was 14 and 16 done online already? Was it? But 14 wasn't. 14 is another one. Oh, was it? Alright. Couldn't find it earlier. And so, I might as well do it again. Alright. Does anybody want me to do 14? Who's attempted it? Honestly. Of those of you who attempted it, do any of you want me to do it? Yeah. Perfect. Alright. That's good enough for me. Alright, let's do it. Maximum height of a projectile is double its range. For those of you that are now bored, my advice is to go towards 17 and 18, okay? I'll catch you up in a minute. Okay? So, 17, so if you have 14 done, head towards 17 and 18. If you want to see 14 done, stick with me here, okay? Now, maximum height of a projectile is double the range. Find the angle of projection to the nearest degree. Alright, we start off a generic throw with speed u and angle theta. So your throw starts there. It's quite a high throw because it's double its range. Not drawn the scale, by the way, okay? The height should be double the range. Okay, so I haven't drawn that to scale. Now, if we zoom in on the throw is going to be quite a high angle pitch, and it should be theta, and then we call this u. What does that mean about the adjacent sides? U cos theta, and what does it mean about the opposite side? U sine theta, okay? Next thing we're going to do are Vx, Vy. So Vx never changes, it's just going to be U cos theta. Vy is going to be U sine theta minus GT. So I'm going to keep it as G this time, because the G's will all sort of cancel later on, so it's no point having it, okay? Now, next thing, Sx is ut cos theta, and Sy, add a t, then half the second one. Alright, great. Now, we got to compare the maximum height to the range. So h equals 2r. So if I drew this accurately, the blue line is twice the size of the green line. I know I didn't draw it that way, but that's the way it should appear. Okay? We need time of flight. Or you could do it cheaper way, couldn't you? What's the quickest way to do this almost? Find the time taken for the greatest height. So what happens at the greatest height? Vy equals 0, so this should be easy enough. So it's going to be u sine theta equals gt, and then for greatest height t equals u sine theta over g. If that's the time to the greatest height, what's the time of flight? We did this double it. What happens when you double it? 2u sine theta over g. Two birds, one stone, alright? Because it's a symmetrical flight. Now, I gotta find the range, and I gotta find the greatest height. I'll start off with the range. Which formula should I use for range, lads? Range being the green line. Sx. What do I need to insert in there? The time of flight for the full journey, which is going to be 2u sine theta over g cos theta, and our answer is going to be 2u squared sine theta cos theta all over g. Right? That there is my range. Okay? Next thing I'm going to have to do is find the greatest height. What formula do I use for greatest height? Or the blue line? Need to use Sy. What time for Sy? Yeah, the Point to the greatest height, so that's no better. In business, half g. I'm just going to square out the point. It's t squared, but I'll input it in as it's squared, okay? So that's u sine theta over g. This one here is t squared, so I'm just going to square it out right away. So it's going to be u squared sine squared all over g squared. What I did there was u sine theta over g multiplied by u sine theta over g. Okay, now that that's done, what we should get is u squared sine squared theta all over g, and this is going to be u squared sine squared theta. That g cancels with 1 and down, so it's all over 2g. And then we're going to do the cheap way out, which is to get them a common denominator. So put 2 there and a 2 there, and your answer is going to be u squared sine squared theta all over 2g. Okay, go with that. What's the description of the question? Gives us what? H equals 2r. So what's my next step then? Yep, I'm going to multiply the range, which is in yellow, by 2. And then I'm going to use this one here, which is in blue. Just going to put it equal to that, because that's the height. So the blue one equals 2 times the yellow one. Okay? So we're going to have u squared sine squared theta. Now, see the sine squared theta? Sine squared theta basically means sine theta by sine theta. Just to let you know. I'll just write it like that for a minute. Make things a bit easier. And then I'm going to multiply the yellow part by 2. So I'm going to have 4u squared sine theta cos theta all over g. Now, a lot of things are going to cancel here. The u squareds are going to go, the sine theta is going to go, and the g is going to go. So you're going to be left with sine theta over 2 equals 4 cos theta. Anybody remember the one rule we're going to use a lot for the rest of your maths career? Yeah, tan theta equals sine theta over cos theta. So you're always looking to make that when you can. So bring the cos theta from the right to the left. And bring the 2. The division of 2 turns into multiplication of 2. 2 times 4 is 8. Tan theta equals 8. Now, a throw of 8 is 1 across and 8 up. Is that what we're expecting? Were we expecting an answer like that? We were, because the height is twice the range. To achieve that, you need quite the high throw. So 1 across 8 up is along the lines of what you'd expect for this type of answer, okay? Then you tan inverse it. And you get a throw of 82.875. Do I have to round it off or anything like that? Or do we say round it off? Nearest degree. So theta equals 83 degrees. Cool. Alright. 15 wasn't done online, was it? No, we'll do 17 next. We'll go to 17, okay? Lads are starting 17, so we'll go there. Alrighty. See, there is 14, is it 14, isn't it? 10, is it 14, and now we're going to do 17. Okay. Particle is fired from a point on a horizontal plane with initial speed 10 meters per second. If the greatest height reached above the plane is 2.5 meters, find the sine of the angle of projection. Not the worst. Just want you to find sine theta on its own. So we'll see how that goes in a second. Yeah, you need to set up your formula, so that's the first thing you're going to have to do. Alrighty. Throw it at an angle 10, and it's theta. So it's going to be 10 cos theta and sine theta. And next thing you're going to do is you get your Vx, which is 10 cos theta. You'll get your Vy, which is 10 sine theta minus gt. Might as well do minus 9.8. Sx is 10t cos theta. Sy, added t and half the second one. Minus 4.9 t squared. Alrighty. What's the, how do we do this? Yeah. Yeah. Vy equals 0 to find the time. So put Vy equals 0, find t value. And then what you say to do with the t value? Put t value into Sy. T value into Sy, and we should be good to go. We're moving on to 18 after this then. We have that one already or not. Okay. So Vy equals 0 would mean 9.8t equals 10 sine theta. T equals 10 sine theta over 9.8. Just leave it like that for the time being. No need to do anything. Then we're going to throw it into Sy. But Sy equals 2.5 when that happens. So it's 2.5 equals 10 by 10 sine theta over 9.8 times another sine theta minus 4.9. Now it's sine theta squared, it's times squared, so I'm going to square that out now. In hindsight, nah, I needed it to be 9.8. I was thinking gravity might be my better option, but I'll do it like this. 10 divided by 9.8, 50 over 49. I'm just going to change it to 50 over 49. And sine theta over 9.8 is 50 sine theta over 49. I'm going to change them all to that. Now I'm going to square that out. 50 over 49 squared. 2,500 over 2,401. It's t squared. That's going to be sine squared theta. Now, unfortunately for us, the lowest common denominator, maybe not. What's 4.9? 4.9 multiplied by 2,500. Divide all of that by 2,401. Perfect. 250 over 49, which is handy for us. So this is minus 250 over 49 sine squared theta. This one is 500 sine squared theta over 49. And this is 2.5, which will convert into 49s in a second. 2.5 multiplied by 49. 122.5. Alright, all the 49s are gone, and I should be left with 122.5 equals 250 sine squared theta. So 122.5 divided by 250. 49 over 100. I'm very happy to see those two numbers. It's no fluke, they're both square numbers. They don't have to be, but happy coincidence. And then finally sine theta equals square root both sides, and you should get 7 over 10. Alright, now you're going to set up a generic throwing angle like you normally do, and your throwing angle will be theta and u. That makes that u cos theta. Yeah. Oh, is it? Makes that u cos theta and u sine theta. Everybody cool with that? That's step one. You're going to make your four formulas. You know, phi x equals yeah, I remember this now, right? So you're going to get phi x equals u cos theta, no bother. Phi y equals u sine theta minus gt. Sx equals ut cos theta. And finally, sy equals ut sine theta minus a half gt squared, okay? Now, I'm going to concentrate on the range, because the range says it wants the range to be as large as humanly possible, okay? You can do this question using differentiation, but you guys haven't done differentiation yet. So I think there's a second method that will make sense. So we'll try that method out today, okay? So what we're going to do is we're going to take the lazy way out. I'm going to find the time of flight first and foremost, because you want to see where it hits the ground and your sy value equals 0. So let's do that first. So we're going to get a half gt squared equals ut sine theta. The t's cancel. Time of flight will equal 2u sine theta over g. Happy days. Throw that into the sx formula. Okay. Oh yeah, see, I just don't know. Yeah, this is difficult. Alright. So there's sx formula is it's going to be u times what's u times 2u over sine theta times g. And then cos theta. Yeah, that's my range. Now, right, there's a formula you guys need to be familiar with now. Here it is. Sine 2x equals 2 sine x cos x. Okay? So for example, sine 60 degrees is actually the same thing as 2 sine 30 cos 30. Want to check that out on your calculator? You can. So sine 60 is root 3 over 2. 2 sine 30 cos 30. Also root 3 over 2. So this is another formula. I'm going to need that in your head. Stuck there in your head. It's large. Right? Now, what do I do with this part here, do you reckon? Haven't told you that. What do you think you do with the 2, the sine theta, and the cos theta? What are you going to change it into? 2u squared sine 2 theta over g. Now, here's the issue, okay? It talks about what angle you're going to use to maximize your throw. Would you agree with that? What angle you're going to use to maximize your throw. So, this part here doesn't matter. So I'm going to highlight the part that doesn't matter. Why does that part not matter? They're fixed variables, aren't they? You throw it at a certain speed. Gravity doesn't change in those conditions. And it's all about the angle, how the angle changes. Now, something that you're going to know is about sine theta as a function, okay? If I said sine 30, your answer would be a half, or 0.5. If I said sine 45, your answer would be 1. If I said sine 0, your answer would be 0. If I said sine 60, your answer would be root 3 over 2. 3 over 2, is that right? No, sorry, sine 45 is not 1. Sine 45 is 1 over root 2, which is 0.707. Right? Sine 60 is 0.866. You're going to use these numbers so often that you're going to need to know them off by heart by the end. I knew these off by heart in school, nearly. You use them that often. And finally, sine 90 is 1. What happens beyond 90? So if I said sine 120, bigger than 1 or smaller than 1? It's actually smaller. So you want to check it out. So, when is sine maximum? 90, exactly. So, so what you say is max value of sine 2 theta equals 1. The maximum value of a sine function is 1. This implies 2 theta equals 90 degrees, implies theta equals 45 degrees. Okay? For it to be as large as possible, you need the sine 2 theta value to be as large as possible. So this yields theta equals 45. There's also a differentiation way of doing it, but you guys aren't ready for that yet, so we'll come back to that down the line. Now, next thing we got to do is we're going to use this 45 degrees to find Sx and Sy. So, to find the greatest height and the range. So what's the range using this value? 2u squared g, and this becomes sine 90. Your maximum range is 2u squared over g. Next thing you have to do is find your greatest height. If the time of flight is 2u sine theta, what's the time to the greatest height? If your time of flight from start to finish is 2u sine theta over g, what's the time to the greatest height? Huh? Yeah. U sine theta all over g. Is that okay? Now, you need to insert that value into the Sy equation, and the Sy equation is here. It's ut sine theta minus, so Sy equals ut sine theta minus a half gt squared. Okay, let's figure this out then. So it's u sine theta, okay? That's what I'm looking for. So let's do that. So ut, so u times u. Suppose we just put in 45, don't we? Save the effort, really. U sine 45 over g, another sine 45, minus a half g times u sine 45 over g squared. Okay, so what's sine 45 multiplied by another sine 45? 1 over root 2 multiplied by another 1 over root 2. 1 over 2. So it's going to be u squared over 2g, because the root 45 and the root 45 equals a half. It's going to be minus a half g. Sine, it's going to be u squared g squared. Sine 45 is sine 45 multiplied by sine 45, which we already know is a half. Okay, so let's see what cancels. U cancel with that one. And then we get u squared over 4g. And we get u squared over 2g. So what's a half minus a quarter? Half minus a quarter, anybody? Quarter. Now, big question. How many times bigger is the range than the height? How many times bigger is 8 times bigger? What am I meant to be proving? 4 times bigger? That's great. Missed something here. Yeah? Yeah. Brian found it. Back up the top here. Remember I converted 2 sine theta cos theta into sine 2 theta? That 2 doesn't belong there. It was just u squared sine 2 theta over g. So that means that's just u. That's 2. Now one of them is 4 times bigger than the other one. My bad. So when I did the 2u sine theta cos theta, should have got rid of that 2. Okay. So we can now see that the height, the range, is 4 times bigger than the height. So you say R equals 4h, and you're done. All right. Okay.